Hello everyone. So let's now solve practice assignment week 11 question number 8 and 9. Let S be a rectangular box. Let x, y and z be the length of the side of the box and volume of the box V is x into y into z. If D denotes the length of the diagonal of the rectangular box, then D is square root of x square plus y square plus z square. Use this information to answer the question 8 and 9. So the question 8 is, if the diagonal is of length 2 units, and the volume of the box is the maximum possible, then which of the following options are true? So we have given that diagonal is defined as x square plus y square plus z square and the square root of 4. Diagonal is given to us as 2 unit, so it is y square plus z square, and I can write z as under root 4 minus x square minus y square. Now what we want to maximize is the volume of the box. Volume of the box is x into y into z. So let's write this function as, this is the function that we want to maximize, but we have one constraint on this function that z should be equal to this. So I can rewrite this function as the function of two variables by replacing this z value with square root of 4 minus x square minus y square. So now I just simply want to find the maximum value of this function. For that, we need to calculate the partial derivative of this function first. Now to calculate the partial derivative of this function with respect to x, we can use the product rule like u into v. So it would be like u derivative times v plus v derivative times u. So the derivative of this would be just y into 4 minus x square minus y square plus xy into the derivative of this square root of 4 minus x square minus y square. To find the derivative of this, we can use the chain rule as follows. We can treat this as some square root of capital X, where capital X here is nothing but 4 minus x square minus y square. So if we just want to find the derivative of this square root of capital X, we can treat it as capital X power 1 by 2, and its derivative would be x power minus 1 by 2 into 1 by 2. So that is 1 by 2 square root of capital X. Now we can replace this capital X with 4 minus x square minus y square, and then we have to take the derivative of this inside function and multiply with this quantity. So this inside here is 4 minus x square minus y square. The derivative of this with respect to x is negative 2x. This 2 and 2 will cancel out, and what we will left with this. So this is the derivative for square root of 4 minus x square minus y square. So the derivative for this is minus x by square root of 4 minus x square minus y square. So we can simplify it as y into 4 minus x square minus y square minus x square y divided by square root 4 minus x square minus y square. We can take the y common, and it would be 4 minus x square minus y square minus x square divided by 4 minus x square minus y square root of this. So this is the partial derivative with respect to x. Similarly, we can find the partial derivative with respect to y also, and it would be, the process would be same. So it will come out x into 4 minus x square minus y square minus y square divided by under root 4 minus x square minus y square. So these are the partial derivative. Now we will equate these two partial derivative to 0, and then we will find the critical point for the function. Now if we are going to equate these to 0, either y would be 0 here or this quantity would be 0. Similarly, if we equate this partial derivative to equal to 0, then also the x would be 0 or the inside quantity would be 0. But as if we are going to get the critical point as 0, 0, now in that case the x and y value would be 0, but we are not going to consider those values. Also, we have to neglect the negative values also, because of the reason we are finding the volume of the box, which is would be in some shape of either cube or cuboid. So if xy value would be 0, then it would be not be form of a like box, and if xy be negative, then it cannot represent as the length of the box or width or height of the box. So that's the reason that while finding the critical points, we will avoid these values which are either 0 or negative. So that means we will only consider those values of x and y while finding the critical points which are greater than 0, strictly greater than 0. So with that keep in mind, let's equate these two partial derivative to equal to 0. So if we are neglecting the case that y cannot be equal to 0, that means this inside quantity has to be 0. So let's first write this as equal to 0. So this is equation 1. And if we equate this to 0, then this is equation 2. So from equation 1, as y is not 0, that means the inside quantity would be 0. So it would be square root 4 minus x square minus y square minus x square divided by square root 4 minus x square minus y square is equal to 0. If we simplify it, we get 4 minus x square minus y square minus x square equal to 0. So 4 is equal to 2x square plus y square. This is the one result that we will get. So maybe we can mark it as equation 3. And similarly, we will do for this partial derivative with respect to y also. So from equation 2, what do we get here is square root 4 minus x square minus y square minus y square divided by square root 4 minus x square minus y square equal to 0. 4 minus x square minus y square minus y square equal to 0. 4 equal to x square plus 2y square. So this is the fourth equation. Now notice in these two equations, 2x square plus y square equal to 4 and x square plus 2y square equal to 4. Their LHS side is equal, so that means their RHS side should also be equal. So here we can write it as from equation 3 and equation 4, I can write that x square plus 2y square should be equal to 2x square plus y square. That gives us x is equal to y. Now we can put this result in any of these equations here and get the value of x and y. So let's put the result in equation 4. So from equation 4, that is 4 equal to x square plus 2y square. Now if we put this result, that is x equal to y here, then let 4 equal to 3x square. X square is 4 by 3. So x is plus minus 2 by root 3. But again, as we discussed before that, we will not consider the negative value here. So we will only consider the case of 2 by root 3, that is positive. And as x is equal to y, we will also get y to be 2 by root 3. So this is the only critical point that we will consider. Notice here that there are more critical points beside these two, but we will ignore those, as the reason is either in those critical points the x or y value is 0 or they are negative, and that's the reason we will ignore them. But if we look at the function, there are more critical points beside this, but this is the only critical point that we will consider. So the critical point is 2 by root 3 comma 2 by root 3. Now we have to check the function value at this point. Also, we have to first verify that whether this critical point is the point of maximum or not. For that, we have to do Asian test, and for that, we need to calculate the second order partial derivative. So, remember, our partial derivative with respect to x was y into under root 4 minus x square minus y square minus x square divided by square root 4 minus x square minus y square, and our fy was x into 4 minus x square minus y square minus y square divided by. So this was our partial derivative with respect to x and y. So maybe we can first simplify this partial derivative as y into 4 minus x square 4 minus 2x square minus y square divided by under root 4 minus x square minus y square, and similarly here would be x into 4 minus x square minus 2y square divided by square root 4 minus x square minus y square. So these are the partial derivative. Now let's find the second order partial derivative. First partial derivative fxx y into, now we will take the partial derivative of this inside function. So it is in like u by v form. So we can apply the quotient rule here. So that is u derivative v minus v derivative u divided by v square. So u derivative is minus 4x into square root 4 minus x square minus y square. So minus v derivative u. So v derivative we calculated it before. So it would be minus x square divided by under root 4 minus x square minus y square into 4 minus 2x square minus 4 minus 2x square minus y square, and this whole divided by v square. So it would be just 4 minus x square minus y square. So this is the second order partial derivative. Now if we calculate the f by y, we will get the similar result for that also. It would be x time minus 4y minus y square divided by into 4 minus x square minus 2y square, and this whole thing divided by 4 minus x square minus y square. So mostly the fxx and fyy are same, and as we will be checking it at the critical point 2 by root 3 comma 2 by root 3, so as x and y value are same, so the value of fxx and the value of fyy would be the same. And now also calculate fxy at the point x comma y, so it would be 4 minus x square minus 2y square x into plus 4 minus x square minus y square into x square divided by 4 minus x square minus y square, the whole divided by 4 minus. This is the mixed partial derivative, and it would be equal to f by x also. Now all we need to check is fxx at the point 2 comma root 3 comma 2 comma root 3, whether it is greater than 0, less than 0 at this point, and fxx f by y minus fx square y, this is greater than 0, less than 0, equal to 0. So this is nothing but the determinant of the Asian matrix at the point 2 comma root 3 and 2 comma root 3 that we have to check. So let's first check fxx at the point 2 comma root 3 comma 2 comma root 3. So this would turns out 2 comma 2 by root 3 into minus 8 by root 3 into 4 minus 4 by root 4 by 3 minus 4 by 3 plus 4 by 3 divided by square root 4 minus 4 by 3 minus 4 by 3 multiplied with 4 minus, okay, so let's write it below, 4 minus 4 by 3 minus 8 by 3. So the whole divided by 4 minus 4 by 3 minus 4 by 3. If you simplify it, it would be 2 by root 3 into 3 by 4. This 3 by 4 will come from the denominator, and into minus 8 by root 3, 2 by root 3 plus, so here this term would be just 0. So that's why this whole term would become 0. So it would be just 0. So it would become, we can cancel this 3 with this 3 and this. So we left with minus 8 by root 3. That is less than 0. Now we need to check whether this is greater than 0 or not. If this is greater than 0, then uh, it that point 2 by root 3 comma 2 by root 3 would be the point of local maximum. So let's check this also. Not if fxx and fyy would be same. So fx x at the point 2 by root 3 comma 2 by root 3 is equal to fyy at the point 2 by root 3 comma 2 by root 3. Because x and y value are same, and we can also look at the structure of the second order partial derivative. It's almost the same, and because x and y values are same, then these value will comes out to be the same. So this would be same as minus 8 by root 3. So let's check fxy value at 2 by root 3 comma 2 by root 3, and this would comes out Now, if we put here x and y value, that is 2 by root 3, so it will be 4 minus 4 by 3 minus 8 by 3. So again this would become 0, so this term vanishes. Now we are left with this inside term now. So we'll put our values here. So it would become 0 plus 2 by root 3 into 3 by 4 minus 4 by root 3 into root 4 by 3. So this would become root 3 by 2 into minus 8 by 3 root 3, that is minus 4 by 3. So if we try finding this value here, so it would be fxx at 2 by root 3 comma 2 by root 3 multiply with fyy at 2 by root 3 comma 2 by root 3 minus fxy square at 2 by root 3 comma 2 by root 3. So it would be minus 8 by root 3 square minus 4 by 3 square. So it is 64 by 3 minus 16 by 9. So this is greater than 0. Now, as this quantity is greater than 0 and fxx at the point 2 by root 3 comma 2 by root 3 is less than 0, that means the critical point 2 by root 3 comma 2 by root 3 is the point of maximum. So because fxx at the point 2 by root 3 comma 2 by root 3 is less than 0 and fxx fyy minus f squared xxy is greater than 0, 2 by root 3 comma 2 by root 3 is the point of maximum. Now again, if we check for the diagonal, we have given that the diagonal is x square plus y square plus z square, the square root of that, and it was given to says 2. So 2 square was x square plus y square plus z square. So x square plus y square plus z square is equal to 4. Now we know that the we want to find the xyz like that such that the volume is maximum, that is this function xyz is maximum. We just found out that it is maximum at the point 2 by root 3 comma 2 by root 3, that is x and y values are 2 by root 3 comma 2 by root 3. So if we just put this value here, 3 plus 4 by 3 plus z square is 4, we will get z square as 4 minus 4 by 3 minus 4 by 3, that is 2 by root 3. Notice both all the x, y and z values are same, that is 2 by root 3. So now if we look at the option, f is a cube because all three sides are same, x is equal to 2 by root 3, and the rest of the options are wrong. Question 9. If the length of the diagonal of the box is 3 units, then which of the following is maximum possible volume of the box? Before, when length was equal to 2, then we got x, y and z as 2 by root 3. At the time, the diagonal value was 2. Now if it is 3, then we can follow the same steps that we did before, and the value of x, y and z that we will get would be 3 by root 3, that is root 3. So root 3 cube unit, that is root 3 cube unit would be the uh, value for x, y and z. If we are going to calculate the volume, that is x, y, z, it would be root 3 into root 3 into root 3, that is 3 root 3. So 3 root 3 cube unit, that is the answer. Thank you.